Okay, so we're going to start factoring today. So the first way we're going to do is factoring when there's a GCF. GCF stands for greatest common factor. So first step, we're going to divide out the greatest common factor, then factor like normal. So the tips of that, look at coefficients first and see if we can divide out that coefficient. Look for common variable in all terms. That's how you know it would have a GCF of that variable. So our first example for this one is 3x plus 12. So I see I have a coefficient of 3. So I have to ask, can I divide both of these terms by 3? The answer is yeah. So if I can, I would bring the 3 out front, and when I divide 3x divided by 3, I'd be left with x. If I divide positive 12 divided by 3, I'd be left with positive 4. And so that is the most factored form. Second example, I have coefficients in front. I can't divide 24 by 16, so I'm going to see, is there another number that I could divide out of 16 and 24? And the answer would be 8. But before I keep going, I'm going to look and say, is there a common variable? They both have a b, so I can bring a b out. And they both have a c, so I can bring a c out. So basically I'm dividing each term by ABC, 8BC. So 16 divided by 8 is 2. B divided by B cancels out. C squared divided by C is C. Then I'm going to move to my next term. 24 divided by 8 is 3. B divided by B cancels out. C divided by C cancels out. So I'm left with this as my factored form. Bless you. Next we're going to look at if we have a trinomial and the a value is equal to 1. So these would be like what we would call the easy ones to factor because there's not a coefficient in front. In y equals x squared plus bx plus c, you must find two integers that multiply to make c and add up to make b, or the middle term. And I put a little tip here. If you're struggling finding what things would work, we can put y equals whatever the c value is divided by x and look at the table. So we'll practice that in just a second. So first example looks like this. X squared plus 7x plus 12. So I'm going to set up my factoring parentheses. And since there's no number in front, I know it's going to be x and x. So what two numbers multiply to make 12? Positive 12, that add to be positive 7. So when I see a positive and a positive, I know both of my factors are going to be positive. And so 4 times 3 makes 12, and 4 plus 3 makes 7. So that is my factored form. On this next one, I'm going to practice showing you how to use the calculator trick, but before I do, I'll set up my little factoring. So the calculator trick is actually something a student a while back taught me, and so I'm like, hey, it works. So if I go to y equals, I'm going to type in the c value, or in this case, negative 72 divided by x, and then I'm going to go second table. And what this does is it gives me all of the possible combinations that would multiply to make negative 72. But realize there's negative x values as well. Now I know that my bigger factor has to be negative because my middle term is negative. So I'm basically looking at what two numbers would subtract to make negative 14. So this would be x minus 18 and x plus 4, because negative 18 plus 4 would be negative 14. So that is kind of the easier trinomials. Next is if the trinomial has an a value that's not equal to 1. So we're going to use what I call the bottoms up. I just totally bottoms up method. Other teachers that I know call this slip and slide. And so I have the steps written out here, but we're going to actually just go do it. So before we ever start slip and slide or bottoms up, I always look at this first number 2 and I ask, can I divide 2 out of everything? No. So always do greatest common factor first. In this one, I can't take that out, so I'm going to let the back number borrow the 2, and I'm going to rewrite it as x squared plus 5x, so 2 times 3 is plus 6. Then I'm going to factor that, so x plus 2, x plus 3, because 2 times 3 is 6 and 2 plus 3 is 5. But then we have this last step. I now get to divide back out that 2 that I let it borrow. So this would become x plus 1, because 2 divided by 2 is 1. And this bottom gets to move up, so it will become 2x plus 3. Number 12 or 2 here has a 12 in front. Can't divide everything by 12, so this one's a even bigger bottoms up. So we would rewrite this as c squared plus 11c, and then 12 times negative 5 is negative 60. So then I'm going to factor that, and it would be a positive and a negative, and I know that because the back number is negative. It's the only way you're going to get a product. And so I'm going to get positive 15 and negative 4. So at this point, we have to divide by 12. And so here's the step that a lot of my students forget. I have to reduce these like fractions if possible. So 15 and 12 are reducible by 3. This would become a 5. This would become a 4. 4 and 12 are reducible by 4, so this would become a 1, and this would become a 3. So I have to reduce those fractions before I bottoms up. So now if I bottoms up, my final answer would be 4c plus 5, and this bottom would move up, and it would be 3c minus 1. Okay, so now we're going to talk about perfect square trinomials. So for a perfect square trinomial, a plus b squared would give us a squared plus 2ab plus b squared. So remember, if we're adding, it's going to have a middle term. So if this is adding here. So let's look at those examples. This is a perfect square, n times n. This is a perfect square, 4 times 4. So it also has a middle term. So I know it's going to be n plus 4, because 4 times 4 gives me 16, and n plus 4, because 4 plus 4 gives me positive 8. You could write it like this, but more than likely on the EOC, that's not going to be how the answer looks. It's going to look like this, because they're going to expect you to know that squaring means something times exactly itself. So that might be what the answer choice looks like. On number 2, I know d squared is a perfect square, d times d, and 25 is a perfect square, 5 times 5. But what you notice is this middle term is negative. So it's going to be d minus 5 times d minus 5, because negative 5 times negative 5 is positive 25, and negative 5 plus negative 5 is negative 10. So again, this could be written as d minus 5 squared. So those are perfect square. Last one is difference of squares. Difference of squares is when there's no middle term at all. So you're going to notice you have a squared plus or minus b squared, and so this is how we factor that. So it's actually easier to just look at examples for this one. So you notice this is c squared minus 100. C squared is a perfect square, 100 is a perfect square, and it's the difference of, because there's a minus. So it would be C minus 10, C plus 10. Or if you wrote it the other way, C plus 10, C minus 10, that is exactly the same, so it doesn't matter the order. So number 2, you're going to notice that 81n squared is a perfect square because 9n, and 25 is a perfect square, 5 times 5, so we would write it as 9n plus 5, 9n minus 5. So being able to see the difference of squares is going to help you not only on your EOC, but especially in Algebra 2, going to help you a lot. I have one more example that I want you to write somewhere on your notebook paper, just because we didn't have any like this. So negative x squared plus 13x minus 42. So none of them that we've seen have a negative coefficient in front of x squared. If you have that, the first thing you need to do is divide out a negative 1. If you do, it'll change the sign of everything, and then you're going to factor. So being able to remove that negative 1 makes it much easier to factor. So we're looking for two numbers that multiply to be positive 42 that add to make negative. So the only way you can add to make a negative and multiply to make a positive is if you have two negative factors. So it would be negative 6 and negative 7. So this could be an answer choice, or they could distribute the negative 1, but here's the thing I need to just remind you. If they distribute the negative 1, they're only going to do it through one of the terms. So it would be like negative x plus 6 times x minus 7, or it could be negative x plus 7 times x minus 6. So just know those answers could look a little bit different. And that's it for factoring.